Alright everybody, so this is PL/SQL, your favorite new programming language slash scripting language slash way to communicate with Oracle databases. So I'm going to give you a whirlwind tour through its capabilities just in case you might want to pick it up and start using it. It's actually pretty easy and it's very functional. It comes in handy for a lot of different things. So why do we want to use PL/SQL? It's a procedural, first of all, PL stands for procedural language, and it works with SQL automatically, so you can integrate procedural programming language statements with SQL statements. Because we all know SQL is kind of limited, and when you type in SQL statements, you're communicating directly with the database. But how do you get information from the user to give to the database? How do you write a little simple program that's going to run right there on the database that's going to allow you to run an automatic backup? And if you're at the My Bank Acme Inc. or whatever, not Wells Fargo, but My Bank Acme Inc., and you're trying to run your nightly batch job, how are you going to get it to run? Well, you can write a PL/SQL script and it'll run for you. And so it's a procedural language, uses detailed instructions, process statements in a sequence. So as a procedural language, it's sort of like a scripting language. It goes from the top to the bottom of the file. Combines SQL commands with procedural instructions, and it's used to perform sequential processing using an Oracle database. So why do we want to do it? Well, because now we have programming language capabilities mixed in with SQL. And it's supported automatically, actually. And there's been still supported and still being upgraded. A lot of programs written in this. I call them scripting kind of programs, though. You're not going to write a full-fledged client-server program using this. It's going to be something you're going to run on the database. Or you're going to embed little scripts, so you can just run a script and it'll do system maintenance and stuff for you, backups and stuff like that. So we have variables. So in SQL we don't have variables, but PL/SQL, or PL, we can have variables. So variable names have to follow the Oracle naming standard. Actually, in general, everything follows the Oracle naming standard. Can use reserved words like begin, number, and table names for variable names, but it's not a good practice to do that. Because then if you're starting to use like variable character as the name of the character, might essentially mess up the logic somehow in your head when you're trying to fix, why in the world did I write this way? Not a good idea, but you can, because PL is not part of SQL. It is a separate language, so you can use anything you want. It doesn't really matter. But it does still follow Oracle because it's written and supported by the same company that makes the database. So it's definitely speaking the same language. You can make variable names descriptive, hopefully. Use lowercase letters, separate the words by underscores. Here's current underscore S underscore ID. A lot of people name the variables by the same name as the data that's in the database. So if you have a column that has first underscore name, you're probably going to call the data that you're going to use first underscore name. The good thing about PL/SQL is it does speak the same language, so you can do a query, take the results, and use them as variables, and actually look at the cursor and work with the cursor as a data structure. What we looked at before lunch was taking the cursor and manipulating it through a driver manager to create a result set from it, and then use that through methods from a higher level API. PL/SQL is a lot lower. It's the cursor you're reading and writing, which is faster. Not only is it faster, but it's more accurate. It is the information that is coming from the database, not something that's been translated and transformed into something else, which, if you're worried about money, you're going to have all your pennies and everything in line. So all variables must be declared prior to using them, just like other programming languages. Syntax for declaring a variable looks like this, where we have variable name, a data type, underscore some declaration, which means it's going to be something. And then we have an example here where it says current underscore S underscore ID space number 6, which means it's going to be a number of 6. So this is interesting. The data types are the same as your SQL queries. So when you create your table and you give a current underscore S underscore ID as the table name, a column name, a field name in your table, and you say it's number 6, well, if you create a variable using the same format, you've got apples and apples. There's no conversion of data from one data type to another. It is the same data type. There's also data types that are built into PL/SQL that represent a row or that represent a table. That's really great because now you can take the cursor, treat it like a table, take each row using a next on it and get each row of information just as if it were from the cursor, just as if you're Oracle reading that cursor information, manipulating that database. It's more true to form, more realistic, more accurate. No data translations, no data conversions, no loss of data, no possibility of there ever being a mismatched data. So data types. We have scalars, which are referencing single values. We have composite values, referencing data structures themselves. References, referencing a specific data item. The references are from the cursor, so it's like a pointer to memory, but the memory are right there in the database that you're pointing to, which is actually really cool. And then large binary objects, or large object binary, are referencing large binary objects, or LOBs, you might say. This actually is brand new support from maybe like the last 5 years or so. In the old days, we didn't have pictures and stuff. The only problem, though, with using large binary objects in a database, it makes your database run like a snail. Because you're putting like MP3 files and videos and content that's big. And you're sticking it in a database table. Every time you query that table, it's got to load. Every time you go through each one of those rows, it's going to make it run like a snail. So a lot of people actually, they'll put, instead of putting the large binary object in the table, you'll put the file on the server, and then you'll have a link to the file. So you'll have the file name, or you'll have the directory in the file name. And that way you can find it in the table and then go get the file off the hard drive, instead of actually storing it in the database table. So many pros and cons to that kind of configuration. So let's talk about data, single value data types. Database scalar database types are, look at that, variable character 2. You don't get this in Java, and you don't get this in C++, and you don't get this in PHP. But in PL, you have a data type called variable character 2 that matches the same data type that Oracle uses for its variable character 2. Well, you should also have variable character as well, but the current version is probably the most that you're going to use. Character, date, number, the long, these are the same data types as your data types that you're specifying for your columns and your tables. Non-database scalar data types also supported as well. We can do integers, we can do decimal numbers for decimal, doubles, precisions, booleans, for true or false, 0 or 1 kind of logic. And then we also have composite data types for arrays, tables, dictionaries, things like that. So we have one called the record. We have one called the table. Java doesn't have a data type called table. It doesn't have one called record or row either. Or variable the array for an array, which would represent something similar to mixed and matched data all in one array structure that would represent a row. If you think about a tabular, row of information that's coming from a query, you could stick that in a variable array, and then you'd have first name, last name, social security number, birth date, all this different data types all stored together in an array. Hard to do that in a regular old programming language. That's why people like PL/SQL, because it's more flexible, works more closely with the data in the database in that structure. So a variable array, by definition, tabular structure that can expand or contract as needed, grows. But how do you know how many results you're going to get back? You're going to have 5 rows back, 10 rows back? You don't know. We also have reference data types. Those are referencing a database item. What does that mean? Assuming that the data type of an item. So we can say, if we don't know the data type of the particular item that's in a row, we can reference in database, in Oracle, in each one of the tables. We don't have to run a query on it. We can actually just say, in this table, find the customer with this row, with this ID, and then give me the row, or give me this column, give me that column, give me that column. No query, which is nice. And you're referencing it like a pointer, actually, but you're using a pointer to the table that's stored in the memory. Because if you think about the concept, Oracle has its own memory structure. When you shut the computer off, you shut the server off, you have files. Those are data files. I'm going to talk about data files tomorrow as well. You create what's called a table space, and you load up data files in the table space. And the table space spans multiple drives, because a table space is a concept like a virtual disk. And inside of the table space, you've got 50 files, 15 files, 10 files, I don't know. And the files are on hard drives. So the physical media is actually storing it with the files, but the concept is take all those files and put it together and incorporate it into a table space. This way you can grow data beyond the maximum capacity of a single drive. You can have, you need more space, well then just put another drive in there, put another 300 gigabyte drive in your server, and then add it to the table space, and then now you got 300 gigabytes more memory to work with. So the table space can grow. Inside of the table space are each one of the different user objects or department objects, or however you have it, the hierarchy created. Inside of those objects you've got the views, the tables, the indexes, and all of the other things that you might have that are associated with the database object. So the whole hierarchy is actually pretty nice. And so if you use PL/SQL, you can go out and say, hey, you know what, for that user object and that table, can you tell me what the B-hacker's social security number is? And pull that information out of the table directly by using a reference. Or you can run a query and reference the query results through the cursor. So assume the data type of an item, you can use, in terms of the wildcard characters, some type assumes the data type of a field. Row type assumes the data type is an entire row. So you can get a row as a result from a database query. Take the row and manipulate the data. So you're looking at, first name, last name, all the different pieces and parts of the data to make more sense out of that. So here's some program structure information. So you don't write a program. It's not object-oriented. It's procedural, which is kind of like other procedural languages. It starts at the top of the program, works towards the bottom. This is the main structure. On the left-hand side over here, we have right-hand side, variable declarations, kind of like, regular old programs. So in the declare section, we have different sections. So we have declare, begin, exception, which means, oh, something happened, something went terribly wrong, and then we have an end section. So in the declare, we're going to declare all of our variables. And then we're going to begin the program statement. So we're going to go from one line to another line, and then we're going to have automatic. So this is sort of Pascal-like. If anyone's ever heard of the language called Pascal, it starts with a begin and an end, and it has different sections to it. This is where it came from, actually. Pascal is a programming procedural language, old language, scripting language as well, but it has a compiled form to it. This is came out around the same time area, so the structure is very similar. It's just kind of like how everything followed C in terms of structure in the beginning as well. So then we have programming lines, and the program lines may span multiple text editor lines, just like C or C++ actually, or Java. Each line ends with a semicolon, same kind of concept. And then the text is not case sensitive, so the text is very case sensitive. Is sensitive. It's not case sensitive, You can write the whole program in uppercase caps if you want, and it works just fine. Hard to read though. Comments are just the same as the other languages that you're familiar with. So the block of comments can be delimited using this old C notation. So we have comments that span more than one line, and then we have the opening and the closing star, the backslashes, and then we have single comments that start with 2 hyphens here. So it's kind of like, in C or C++ or Java, we've got the 2 backslashes that work together. So now we got 2 slashes instead of backslashes for commas that are only on one line. Comes in handy. So I'm not going to go through all this. Just going to kind of give you an introduction and a brief overview of the language, just in case you're interested in partaking in something like this. Arithmetic operators also exist: exponential, multiplication, division, subtraction. We also have assignment statements. This is the Pascal-like kind of thing. So instead of an equals, we have a colon equals. So syntax is a little different. So variables are assumed to a new value. It's basically on the left-hand side of the operator. So new value is on the right side of the operator. So student name would be equal to John Miller. Student name would equal current name. If current name was current student, if current student was a variable, it would be automatically assigned. So displaying PL/SQL output in the SQL Plus window. This is the interesting part. So normally PL/SQL is used with other Oracle utilities such as forms and reports. In fact, if you venture out into Oracle reports or Oracle Developer or Oracle Forms, you'll see PL used all over the place. It's the scripting language that's supported by Oracle, essentially. And so it's not a bad idea to become familiar with it, especially if you're going to use these add-on products. But you can also do it in the SQL Plus window, which is the command line interface if you've played around with that. So commands to activate the memory buffer in the SQL window can also be used. What do you mean by memory buffer? Well, if you're creating sort of a programming environment for yourself, you might want to say, well, in the memory of this running program, I'm going to declare a variable, and then I'm going to use the variable. Well, if you declare too many variables, you're going to run out of memory or environment space. So you can set the size of your environment space to suit your needs. Then you can clear the environment, expand the environment, do all sorts of things to it. So here is a set server output on size and then creating using a buffer size variable, which is equivalent to setting the server output on size 4000, which basically you're going to create the buffer that your program is going to use, essentially. And now when you create the buffer, you can fill it up, and you're not usually utilizing other memory on the computer. So this is temporary memory that's accessible for the life of the PL/SQL running program. So the command to output data from the PL/SQL command window is a dbms_output put line, which is kind of different. This is commands if you're going to use PL in the SQL Plus window. Otherwise, PL is incorporated into the toolkits. So you're writing PL syntax, but you're generating it through a GUI or using it through the forms or the reports. So you're using the language, but you're operating a little differently in terms of the input-output because you're using controls that are built into another interface. So it's the underlying logic that you're programming that you want to be familiar with in terms of the syntax and stuff. So the input-output, you can put a line out on the screen. You can also do this with non-console applications. You can do it with GUI. So PL will work with a GUI module that will give you, forms and stuff like that, which is nice. Because then you can create a nice little PL program that loads up and an admin sits there and fills out forms all day and turns stuff in, and it does automatic updates to the database, as an example. Not too bad. So executing a PL/SQL program, you would copy the program code from Notepad into it, or you can actually load the file. So it's regular old text file that you're creating and putting the source code in. And then you type in, after you've loaded it into the environment, then you're pressing this / to execute the code. And when you execute the code, it'll run your program for you, which is no compilation. Although there is a compiled version of PL/SQL, you have to get the third-party tools that are going to work with it. That'll create an executable file for you, if that's the case. But most people would use it as a lightweight scripting language inside of the SQL Plus window or inside of another toolkit. So in terms of the data type conversion functions, these are the same things that we have with the functions that you get with SQL. So now you know SQL, you can actually program PL/SQL a lot easier because it's the same functions that you're running. So the toDate, the sum, the average, the minimum, the maximum, all those functions are the same. So toDate, characters, and there's more in PL that does not support it in SQL. So here's a toDate function to number to character as an example to convert your data appropriately. So we also have character string functions that can be used for concatenation. For concatenating example here, strings. Join two or more strings together with a single string. Concatenation operator are these two little things. Why didn't they use plus? I don't know. Everybody uses plus, but this is an old language, kind of derived out old stuff. This is really sort of the double pipe symbol in Unix, so it's a pipe. Take this, send it to this, and send it to this kind of concept, which is probably where the symbol came from initially, but think of it sort of like concatenation in this particular case. We also, and the reason why we have to do with concatenation is kind of easy actually. When you have data in a database, it's all spread out. When you do queries or you look at the tables, the first thing people want to do is put it all back together. How do you put it back together? We got to take all those separate little strings and concatenate them together in order to get them back together, which is kind of interesting. In fact, when I talk about normalization tomorrow, you look at this and go, why do we want to even use a database? Because really what we're doing is taking a bunch of data and spreading it out all over the place. And then we got to normalize it to make sure we don't have any duplicates, we don't have any inconsistencies, and we can match it all back up again. And then we use a language like PL/SQL, and that's all thing we do is we care about putting it all back together again. It's like, why do we break it out then if we're going to put it all back together eventually, and then we have to worry about all the problems associated with breaking it all out. Doesn't make any sense, really, but it does in the long run. It's a more permanent, more stable way of creating a structure for the database that outlives the reason why we're using the database. So if we kept it all together, we may, we may end up in a situation where we're going to use it for not the intended purpose that it was created for. So we end up with having to parse it out. So if you start it with it all parsed out to begin with, then you can put it together any way you want. Long story short, but I asked my little diatribe on why in the world do we want to break out the data. So in terms of PL SQL characters and string functions, here we have a right trim, left trim. We have to upper, to lower, upper, lower. What? I don't know what he's doing to me. Hold on one second. I'm sorry, were you trying to get my attention?
Yes.
Yes? What can I do for you?
Yeah, can you use the mic that we have?
Do you want me to test it out?
Yeah.
Okay, hold on one second. Let me pause this. I'm recording. Pause. Alright, I am resuming my capture with audio sound. Stopped on slide number 19. So, let's see. I like this. This sounds pretty good. And actually, I have freedom of movement. Wow, I can move. It sounds pretty clear in the back. Oh, wow. Wow. I think this looks pretty weird, though, doesn't it? Okay, it's upside down. All right, so we have right trim, left trim, upper, lower. I feel important now. Length. I don't know, all these different functions that we can use to manipulate the strings, string characters. We also have INSTR, which is going to be in string. So it's going to search the string and look for matches of substrings and return the starting position of the substring match. Why do we want to do this? Because we've done a query on the database, we have the results back, we've added it to an array. Now we want to search in to some of the strings to see if this particular person is in our row results or something. So we're going to essentially use a temporary variable, maybe have a starting position and have it equal to the string where there's a string being searched, which is going to be inside of another string. And we also may have a situation where we have a blank string. It's going to be a string that's going to have, let's say we're looking for the spaces between a string. So we can get substrings out of the string as well, which makes it handy for string manipulation or string processing. So I feel like an alien with this thing on my head. Here's the substring function, and it extracts the specific number of characters from a string starting at a given position, or starting point. So we extract string is going to be equal to a substring with a substring that's being searched and a starting point, and then the number of characters to extract. So if we know, for example, we've got a big database dump of all this data, and we want to get all the first names, and the first names are, the, say, for example, the second column in the row sets that are returned, and we have 5,000 columns that came out of this, or 5,000 rows that came out of this, then we can use a extract string and just pull out all the first names, pull out all the second names by using a strict position of the character strings. So we can extract out the strings that match any particular type of pattern we're looking for, or just take at some starting point this particular amount and then call that the first name. So here we have the example. Here it says first name is equal to substring Sarah 1, 5, Sarah Miller 1, 5 in terms of the example, which comes in handy when we're trying to manipulate data. So debugging PL SQL programs, we have the concepts of there being logical errors and then syntax errors. So we don't have, PL is not a compiled language, it's a scripting language. So we never have any compiler feedback that tells us that there is a bug in the program or a problem in the program. Instead, we run it and we see what happens. And unlike other scripting languages like HTML, which is markup language, but let's say JavaScript as an example, where nothing happens, instead now we can actually, it's more sophisticated, a lot more powerful than JavaScript. We have errors that can come back with messages that can tell us that on this line of code, we have a malformed assignment or something, or that this is not a number, or something that's going to come out of it. So syntax error does not follow language guidelines. If you're creating a syntax error, it causes PL compiler errors. In fact, there's a compiler version of it where you can actually test the code and make an executable out of it, and then you'll know if you have any compilation errors. Examples of these things might be misspelling a reserved word, using a function incorrectly, something of that nature. We also might have logical errors, or logic errors, where the program compiles correctly, but it doesn't give the correct output, either because you've used the wrong field, or you've got something not set appropriately. So locating and correcting syntax errors. We can isolate the line that's causing the error. We can put comments in there to kind of debug it for us. Might actually happen before or after the line that's flagged by the compiler. We can comment out lines to see if the problem goes away, if the problem does run. Or we can also do one error may also cause several other cascading errors, and we can try and fix error by error, and then rerun the program to see if each error is actually fixed, which is kind of another way of doing it. And you might get the impression that this is kind of primitive debugging, which kind of like, basic stuff without any tools, and that's what's available. So if you use one of the more sophisticated PL interpreters, which there are some on the market, they're not free. You actually have to buy them from Oracle. And then you'll have more sophisticated debugging tools as well. But the base language is only going to come with, trial and error type of debugging issues. So locating and fixing logic errors is a little bit more trickier. I'm not quite sure what happened with you're seeing funny stuff too on the bullet points. Okay, not quite sure what happened with that. So we can identify the output variables and that are causing the error, identify the input and the calculations that contribute to the errors, and maybe display the values of the inputs using a DBMS output command, or take a break and look at it later. Ask a fellow student, ask me, ask somebody for help. Those are your troubleshooting techniques, PL/SQL, unless you're using a paid-for tool. So in PL/SQL, we can also, again, just the same way as we saw with the JDBC and the ODBC interface, we can take and look for null values. So unknown and null and not null all work in this interface. So until a value is assigned to a variable, the variable's value is null. Performing an arithmetic value on a null value always results in a null value. So we have the three-way logic that we normally have in SQL. So we have the null, it's going to give us a null, or a null in anything is going to give us a null instead of a 0 or instead of a blank, which is helpful. Some advice is to always initialize variable values. Variable values are not initialized on their own. Instead, you have to manually initialize them. If you don't initialize them, they're going to be null, which means there's no value assigned to them, which is going to cause a problem, essentially. So then we have selection statements. So we have variables, and we have primitive kind of constructs that are used for multiple selections and single selections. So here we have the if-end kind of construct that we're all familiar with in other programming languages, the if-else and if kind of construct, which is kind of different. So if a condition, then, so we have to actually put the then in here. We actually put, this is very Pascal-like again as well. In fact, it's very Visual Basic-like as well. So we go if, and then some condition exists, then we have to actually write in then, and then we have to go end if. So we have to if and an end if, which is kind of different. There's no opening and closing curly brackets. There's just statements that come in. So because it is a procedural language, it definitely follows through the traditional procedural style of programming, which doesn't use blocks. It goes through and reads line by line, and it takes keywords to adjust its flow. So the then is very important because it doesn't know what to do if a condition. And then you have to go then. Or you can go if a condition, then run some program code, else do some alternative program statements, and then end if, essentially. So here's an else if, also supported, very Visual Basic-like as well. So if a condition, then run some program statements. Else, if there's a condition, then run something else. Else if, and then end if. These are actually kind of important because this is what you're doing with a procedural language. You're running a test on the database to see if you're going to get information that's going to come back that's going to meet a particular condition. And then if it does, then you're going to do something. So if the customer is already in the database, then don't add them. Otherwise, insert into something or other, customer's first name, customer's last name. So the point I'm trying to make is that you're mixing this stuff in with SQL. So it allows you to do an if-else, to do some sort of a check on a condition, and then perform different commands depending upon what's going on. So you mix and match programming statements with SQL statements, which makes it very powerful in the end. So PL/SQL comparison operators, looking at here, we have the operator, the equals, the not equals, the greater than, the less than, all the things you might have in other languages as well. In terms of evaluating the null conditions in the if-then structures, if a condition evaluates as null, then it is false. Well, it can't be true. So anything that's just not true is going to end up in the false category, including nulls. So how can a condition evaluate as null? Well, that's an interesting one. It uses the Boolean variable that has not been initialized yet, which might be the case, or it uses another variable that has not been initialized yet, or it's pulling something out of a database and the information it pulled out was null. So then it was null, so it's set to null. So having the null value for variables that are not initialized, or variables where we didn't have anything, so nothing came out of the database, so we couldn't assign it to a particular variable, so it ended up being null. Kind of handy, actually, for troubleshooting. So using SQL commands in PL/SQL programs. So the SQL command categories we have, as we've seen at the beginning of the course actually, the data definition language, the DDL commands, and then we have the data manipulation language, manipulation commands, and then we have the transaction control categories of commands. And these are just general categories of different command types that can be used, and some examples of which falls into which category. And then we have can be used in PL/SQL. Actually, this is not true for the current version. You can actually do all of the commands right now. In the earlier versions of PL, it didn't allow you to define tables because you never needed to. Who in the world would want to create a table using a scripting language like this? Instead, you were at the database, you might as well just create it yourself, right? But then people figured out, well, there's remote logins and stuff, and you can give them access to the script, and the script's going to allow them to create tables, but they can't do it because the command's restricted. So then it's been expanded on. There's packages where you can actually load in modules for even more types of SQL statements as well. So it's an expandable language as well, which is sort of like Perl with modules that you can add in. So you can extend the language to make it more robust, more feature-rich. So we also have loops with PL/SQL. So the loop repeats one or more program statements multiple times until the exit condition is reached. And so we have a pre-test and a post-test to this loop. So the pre-test, the exit condition is tested before the program statements are executed. On the post-test, the exit condition is done after the program statements are executed, which kind of gives you, it's kind of like the do-while, where you have a while, and then you have a do, or you have a do, and then you have a while, which means, sometimes you're going to test the condition before the loop starts. You're going to let it go once, or you're going to do it after it loops. Well, if you let it do after it loops, it goes once automatically. If you test it before the loop, it's never going to run. So if you want it to run at least once, you do the test after, do a post-test. And here's our loop. It's actually called a loop. There's no do, there's no while. It's called loop, L-O-O-P. So loop, and you have the program statements in here, then says if a condition, then exit. And then you have an end if that occurs. Then you have more program statements, and then you can end the loop. So there's a pre-test or a post-test that's associated with that in terms of the way that you're designing the loop, how you're going to run it. So in terms of this here, we can run it both ways. And here we have a post-test where we're going to loop, and then we're going to end the loop if we exit out. So either we're going to run constantly, or we're going to have an exit when some condition occurs. So the exit when is controlling the loop, and then we have here the condition, if a condition, then exit, that's basically done in a loop. It's the same thing you're doing actually with a while loop in a traditional programming language. While x is equal to, while x is less than 100, and then inside of the loop you're going x minus minus, x minus minus, so it's eventually going to be less than 100, or whatever it happens to be. We also have the while loop. So here's the while condition, and then while condition loop. So the loop is actually going to create the iterative program execution. The statement's being executed one after another until the end loop occurs. So while a condition, then enter into the loop, or for a counter. So if you're familiar with C++ or Java, and you have the for, for I is equal to 0, I is less than 5, I plus plus, and go through 5 times on an I. Same kind of thing. So for some counter variable in, here's where in, where's in come from? Well, that's an in that we looked at in SQL. So we have exists, not exists, in, not in, all of those expressions that you looked at with the SQL lecture, all of those are actually part of PL/SQL as well. So you can use that syntax. If you're familiar with it from SQL, you use it in the programming language, which makes it a little bit different. So we have the starting value to an ending value. If it's in there, then loop. If not, end the loop, kind of thing. So here's our cursor concept again. So the pointer to the server memory location. So here you see another definition of the cursor. So pointer to server memory location. You're like, where's the server memory location? Well, you can actually configure the cursor. You can make the memory size bigger. You can move it. I can't move it very far, but you can partition it out. There's a couple of different configurations you can do to it, but for the most part, people are going to leave it alone. They're going to just use it as its main purpose, which serves as memory. So it contains information about SQL commands in the PL/SQL program, and it's called the commands context area. Well, I don't really call it a context area. I call it a memory. It's the memory that's associated with the commands that are running. And here's an example of a database memory server. So the cursor, as I was mentioning before, and this might give you a little bit more information about the concept, because cursors come into place with scripting languages, with JDBC, with ODBC, because we're reading and writing to the cursor, which is the server memory, when we're using these utilities. Outside of that, we have other interfaces like the PL/SQL or the SQL Plus window that we're going to get output to, but it's coming from the cursor. Anyway, so here's what they're calling the context area, which is this area here, and then we have the active set, which is the current result set that is coming out of any query that we could have run. And then we have the cursor memory, so we have the metadata that's stored for the cursor. In this particular case, we have the number of rows that are being processed, and then we also have the parsed command statement that we gave it. So in the cursor, we know that we did select star from employees. There it would show up here. And then it'd come back and say, oh, there's 5 rows in this particular case that were retrieved, so we keep that information. So we can ask the cursor how many rows were retrieved from the database, and it comes back and says 5. Or we can say, well, what command was that? And then the cursor itself is organized by its command statements. So we can go back 5 commands or forward commands, and we can kind of traverse through the data to see what it is we're trying to be looking for. So, all right, so we have 2 different types of cursors that we can create, implicit and explicit cursors. So once created for us automatically, in fact, you've been using cursors if you've been using Oracle, because it's created for you automatically every time you run a query. There's a cursor. So implicit cursors are they're created automatically every time you run an insert, an update, a delete, or a select command. Not a join, not some of the other ones, but on the insert, update, delete, and select, it's going to essentially create one for you automatically. It doesn't need to be declared. You don't have to say use a cursor. You automatically get this behavior happening for you. Can be used to assign the output of a select command to 1 or more PL/SQL variables as well. And can only be used if query returns 1 or more record. If it doesn't return anything, you don't have a query. You don't have a cursor. Well, you don't have cursor information. You still have a cursor. But it's going to be empty because you don't have anything that's going to come back out of it. So in the implicit cursor syntax, we're looking at a select field 1, field 2, into variable 1, variable 2, from a particular table. So from the table where, we got the search condition that will return a single record. And then we've automatically created, implicitly, we have the cursor syntax created for us. The other option that we have is the explicit cursor. So the implicit, you don't do anything. It happens automatically. You just run a query, you're going to get it. So that's the way that the database works. with an explicit cursor, you must declare the program in the declare selection, and then select. It basically can be used to assign the output of a select command to one or more PL variables, and can be used if the query returns multiple records or no records at all. So when you explicitly do it, you're creating it and it's just going to be empty. It's not going to return anything. So using explicit cursor in the declare, we declare the cursor, we open the cursor, we fetch the cursor results into the PL/SQL program variable, then we close the cursor, which is sort of the manual way of doing what Oracle does for us automatically. So we say, there's going to be a cursor, here it is, it's going to be called cursor 1, open it up, run a query, put the results in cursor 1, and we can use cursor 1. It's kind of like taking, this would be nice to have a program that does this on your, for other languages, to say, we're going to use this memory for the output of this command, and create the memory, here it is, open it up, run the query, put the stuff there, and then keep it for later. So it's kind of like how we load stuff into memory using pointers in C and C++. Same kind of concept. We just read and write to memory locations and then change the pointer to the memory location. So cursors in some ways are like using pointers, but you're not using a pointer. So instead you're doing pointer activity and accessing things as if you were using a pointer. The same kind of concept. So in terms of declaring an explicit cursor, we use declare cursor. Say we call it a cursor, give it a cursor name, and it is select this statement from that statement from that statement from that statement. So I don't know who that was. Maybe it was you earlier said, is there an is? And there is an is. And you said that it reminded me of it. And I'm like, no, but it's not in query. It's not in like regular SQL. It's in PL/SQL. There is an is. Because that's how you're defining, this is the cursor name, and the cursor is select star from employees where first name is equal to something or other. So it's an assignments expression. There are some syntaxes of SQL that use an is, however, for the same kind of purpose, but it's not working with a cursor. So opening an explicit cursor, we can say open cursor name, and then we're fetching cursor results and say fetch cursor name into variable names, and then close the cursor. So we say close this cursor, whatever we're calling it, cursor 1 or something. Hopefully we're getting that a more meaningful name. So processing an explicit cursor, we loop, we exit then in terms of the looping approach. So open cursor, loop. And what I'm going to do, we're going to fetch the cursor name, whatever it happens to be, cursor 1, into variable name. Exit when the cursor is not found, when there's nothing left. So we're reading from a cursor, putting it into a variable, and then we're going to loop. And then we're going to end the loop, and then we're going to close the cursor. So it is kind of like using a pointer, but it's a lot more steps because it's a procedural language than it is to say, hey, go to this memory address and get this piece of information and use this piece of information for something. So the cursor for loop approach. So for variable name and cursor name, loop. And then we have some additional processing, different statements that will happen before the end loop occurs. So using reference data types in explicit cursor processing. So reference data types aren't referencing like pointers. The cursor is sort of like the reference that you're familiar with in traditional reference types for traditional programming languages. This reference type is not referencing the cursor, it's referencing the database. So instead we have a reference type that's going to give us the row, the table, the row, the view, the index, the sequence, whatever happens to be the item we're interested in referencing. So we reference this table and we fetch information out of the table in terms of the process. So we can declare a row type reference variable. And here we have declare, and so it's going to be the variable name. It's going to be cursor name, let's say, and it's going to be a row type in terms of the data type that's going to be assigned to. And then referencing the row type reference variable, we can do it the same way. We just go reference variable name dot database field name. So I can say if I had a table called employees, I can say, and I said, well, let's reference this table, and it's a table type, not a row type. And let's call it employee table. Then I can say employee table dot first name, employee table dot second, last name of, and I'm looking at it from a column perspective. If I wanted to get a row from the database table, I'd have to run a query, then define a row type, variable and then assign the row to the variable. And then on the row go, okay, so result dot first name, result dot second name or something to get at the data components that are inside of it. So let's see, we have attributes that are associated with it. Here's a kind of a concept here at the PL SQL table. So we have data structures in PL that act as tables. So we can create a table, just like we would create a variable, and then we can use it to store the contents of our table if we don't want to reference it. Or we can just reference the underlying table. If we reference the underlying table, we're not running a query on it. We don't have to run a query on it. We just get information out of it that we want and use it from a programming perspective rather than an SQL one. However, it might be possible to take a result set, put it into a table, and then query the table, or do something with the table inside of the script, which comes in handy. So here we have a data structure that contains multiple data items that are the same data type. So we have a key-value relationship. So we have key 1, 2, 3, and then we have some values that are associated with the keys, shadow, dusty, sassy, as an example in this particular case. And so that each table item has a key and a value, so a key-value pair. And the key values do not need to be sequential. They can be anything you want, actually. It's just like a dictionary lookup where we have, in fact, they don't even need to be, the keys actually don't need to be numbers either. You can have 1, 2, 3 spelled out in characters if you wanted to. So you can use it to create a lookup table that's stored in memory to basically improve processing speed as well. So the table structure can be used in a couple of different ways: to speed up memory, to create a faster lookup, also to manipulate data a little bit more efficiently. So table of records. So the PL SQL table can store multiple values that are referenced by a key, we've seen. So usually used to store database records. So you need to be that need to be processed. So we run a query, we get the results. We take the results, we put it in a table, we create basically a database table. And then we use the table structure the same way we don't use the underlining table structure. It's sort of like creating a view. But you're not creating a view in the database. Instead, you're creating a view, you're creating a table that contains the view of what it is you're looking at from the query results. So this can actually speed everything up, make it a lot faster, and put it so that your application is running extremely fast in terms of its lookup, because it's only going through the data that applies towards what it's looking for. So improves performance by limiting the number of database retrievals as well, because once you've run a huge query, select star from this table, take the table and put it into another table, which is the same concept. A table in a database and a table in PL/SQL, they're the same. So put it in the table, or put it in a lookup table, as this example was actually showing, with an index. And then what ends up happening is you don't have to go query the database anymore, because you're not using it from the database. Instead, you're using it from the temporary memory that you've created for the PL/SQL script that you're running, which makes it run a lot faster. Exception handling. So all of the error handling statements are placed in the exception program block. So PL/SQL will actually do exception handling for you. It will actually catch errors, and you can put predefined, catches for it. So if this error happens, do that kind of thing. So exception handler itself is a program command that provides information about the error and suggests corrective actions to be taken if the error exists. So here's those lovely aura messages I've been talking about. So common errors that have been given predefined names and appear instead of error number codes. So the error code aura 0001, unless you really like that code. You don't have to use it. In fact, you can change it and say unique constraint violated. So it gives you the ability to and then this is the exception name. So the exception handler and the exception that's built into PL/SQL allows you to take the built-in codes and the built-in exception names that are predefined and give it a meaningful explanation. So when your program encounters this exception, it can print out unique constraint violated to the user or something instead of its crypted aura 0001 or whatever happens to be associated with it. And don't take these as the real errors. I don't believe they are. So exception handler syntax and predefined exceptions can be used. And here we have an example. And how are you going to know it's predefined? Well, you're probably going to get a book And the book is going to have all of the different messages in there. So this thing is eating into my scalp. I don't think it was meant to be worn this way. I don't know, but it's definitely, I think because when you went like this, it's like really tight. If I pass out, it's because my headphone is too tight. All right, so when this exception occurs, then this happens. When this exception occurs, then this happens. And it's primitive, but it works. And the exceptions are raised by Oracle, so they're Oracle expressions, so they're easy to catch. You don't have to, and if you use the built-in ones, you don't have to define them yourself, and you can easily capture errors and easily see what's going on. We also have undefined exceptions that are less common errors, and they have been given pre-defined names. So ORA error code might appear, and then an exception handler that might test for an ORA error code and provide alternative error messages and say, hey, some unknown exception occurred, or something happened. What am I going to do? Well, you're going to run this code, or you're going to do something to handle it. You can also define your own, which is another reason why it's kind of nice. So in JDBC and ODBC, we get limited error handling, and we don't get any exception handling, and we certainly don't see any Oracle errors. In PL/SQL, we get it all. We get exception handling. We also get a lot of built-in, predefined exceptions, and these are the Oracle exceptions that occur. So it's definitely a one-to-one kind of handling with no interpretation. Just get the messages back. We can also define our own exceptions. So the errors that will not cause a runtime error but will violate business rules. So the programmer creates a custom error message. And then we have the concept, and in fact, if you're going to create a custom error message, you're going to use it the same way as you use the built-in error messages, built-in exception handling, I should say, predefined codes. So we can also nest programs inside of other programs. So the structures all look the same. There's a declare, a begin, exception, and an end. And then, believe it or not, all of it at the end has a semicolon. That means we're done with this procedure. So its procedure is more like lines and lines of instructions from the start to the end, and then we're done. So in this particular example, we have an outer and an inner box. And exception handling is pretty much done the same way. It's caught, and then you're returned to the from the inner to the outer. The interesting thing is we can pass information from the inner to the outer, and we can use it inside of the outer exception if an outer exception is being handled. So an inner program block can be nested within an outer program block in this particular example. And then if an exception handler is nested in the program block, if an exception is raised and handled in the inner block, the program execution resumes in the outer block. Doesn't bomb the program out. If you have an exception that occurs in a Java program, C++ program, PHP program, JavaScript program, well, usually if you have an exception, the whole program just bombs out completely. If you're lucky, it might continue. It's nowhere near the same level of freedom you have with this. So here, it's because when working with databases, there's more exceptions than you could possibly imagine. It's not controllable. How do you know what the user is actually going to try and input into that database? And how do you know it's going to be correct? So there's always bad input. There's always results that come back that are not good. Databases are messy. By data structure itself, it's pretty messy and could be uncontrolled. So long story short, PL/SQL has a lot better exception handling, and it has nested exception handling. So you can go from an outer to an inner block, or from an inner to an outer block, retain the information and control the flow in which something is going to execute next and something is going to resume. The whole program is not going to crash on you. Which means just because person X has a bad social security number and we can't update the file, we skip X and then we go down to Y, and then we can continue going down to the rest of all the data. And then we can have a report that prints out if our exception handling is writing something to a log, as a good example. And then at the end we can look at the log, because we're going to write PL/SQL programs to do automated backups, to automated updates, used for batch processing all the time. Because you're not going to be up at 2 o'clock in the morning if you work at the Acme Bank Inc. and you're not going to be doing this manually for 4 or 5 hours straight. No, you're just going to probably not do anything, have it on a timer, and then it happens automatically. And throughout the night, who knows what's going to go on, but in the morning you can check the log from all the exceptions that occurred and go, oh look, user X doesn't have any money. Oh, that check bounced. Or, you know, oh, this happened, that happened. And then usually you have bank people actually go through the log and go, what happened with that? What happened? Oh, look at that, bad check. You know? And then they can kind of figure out what happened from the night before. Because not all these transactions are going to work perfectly. And so the exception handler can control what happens in which order. So exception handling in nested program blocks, when the exception is raised in the inner block, it can be handled by the exception handler in the outer block as well. So if you had an inner block problem, the outer block can actually take care of that for you. So that was everything you ever wanted to know about PL/SQL, or didn't want to know, I don't know, about PL/SQL in terms of a programming language. So what I want to do now is stop this particular recording. Stop this one.